Hello everyone. This is the first time I am creating a Unity tutorial video. In this tutorial I am going to show you how to create a world position based shader. This entire project is using URP. If you want to create a URP project yourselves, what you can do is go to Unity Hub, and while creating a new project, use this universal 3D template. Alright, so when I was developing my game Whole Journey, I came across this requirement where we had to create platforms of different shapes, but like each corner would be curved. So such platforms we had to create. So we decided to create tiles for each different corner and the center. So I have this center tile right here. As you can see, if I move it, you can see how it is getting combined with the other tiles. Now, once we had developed this, we came across the problem that the texture that you are seeing here, it is not continuous all over these tiles. So what we wanted was a continuous one where, like no matter how many tiles we add, it will always be continuous. So to solve that problem, we decided to create the world position based shader. Now, first of all, you can see that in these prefabs that I have created, we have this grass material. So this is the material which is here. If I change its, let's say, tiling or offset, it will get reflected here. Also, the texture which is being shown here is there in the textures folder. So let's get started with the new shader. So what I'm going to do is go right click, create, and let's go to the shader graph, URP, and create a lit shader graph. Let's name it world position shader. Okay, done. And let's open it right here. Now I'm going to reopen this material to show you what fields will be required in this shader. So first of all, we can see that a base map is required. So let's add it here. So for a base map, we need a texture 2D. Let's call it base map. Then we need the smoothness. I'm not using anything for the metallic map. So let's just use this smoothness value. So go here, create a float, smoothness. Then next we need the tiling. So for tiling, it is 2 dimension, right? So let's go to vector 2, tiling. Then finally we need the offset. So offset. All right. So since we are not going to do any changes in the smoothness, let's first assign it the value 0.5 and then drag and drop here and assign it back to the smoothness. Next, let's go to the base map and drag and drop it here. As you can see, I cannot directly connect this base map to the base color. Now, what is happening here? What is a base map? Let's try to understand that. So in the Unity, we just saw that base maps type was a texture 2D, right? It is a texture. Let's try to import the same texture in Microsoft Whiteboard. All right, so I have this texture and this is my base map, right? So let's draw two axes here. One we will have here and the another one there. This, let's say, is our x-axis and this is our y-axis. So a texture, what exactly a texture represents is that it has different pixel values for each x and y. So let's say if I give it an input like x1, y1, right? Somewhere, let's say this point, x1 y1. In return, it will give me r, g, b, and a. These four values it will give me in return. R stands for red, G stands for green, B stands for blue, and A stands for. Put a comment in the comment section and tell me what A stands for. Alright. Now using this R, G, and B, we can produce any color that we want. So a texture basically has RGBA for each x1, y1 position. Alright. So that is clear. Now let's go back to Unity. So now that we have this texture map, base map, we have to pass it to the base color somehow, right? So to do that, what we have is a node. We have to add a node. So what we do is press shift, and here I'm gonna search for sample texture 2D. All right. So this is the node that we are going to use. So let's click on it. Sample texture 2D, and its first input is a texture. So let's pass our texture, and in return what it is giving is RGBA values. And now I am able to pass it to the base color, right? And you will see there is another input that it is taking, which is called UV0. So what does this mean? What does UV0 mean? And what does this RGBA mean? What exactly are we returning here, right? Let's try to understand that. So let's try to create an object here. Now for a cube, what Unity will do is Unity will create an array, okay, of positions x1, y1, z1, something like this. Okay, so all these positions will be there in an array, and for each position there will be a color like this RGBA that we just saw, right? A color will be there. So another array will be created where colors will be there for each of these positions. And this color array, this will be passed to the base color property of the URP. So let's go back here. You can see this base color, right? So it will take this RGB value from here. Okay. So how this conversion is happening? How does Unity know what color value is going to be shown there? We have given it this input, right? But there was another input called UV0. Okay, what does that mean? So in order to convert a position to a color, what each 3D software does, it creates a UV map. Okay, a UV map means there are two axes similar to this. Let's say a U and a V. These two axes are there, and your texture is present here along this axis. Okay, so each position from here, right, it is put somewhere on the texture. So let's say this position is put here. All right, what this means is that if you pass it to your UV map, okay, if you pass it to your UV map, your UV map will give it this color, that hey, this color is supposed to be there on this point. Got it? So this conversion from the positions to the color is done by a UV map. Okay, and a particular 3D model can have multiple UV maps in it. UV0 is one of those maps. It is a default map. Okay, the first one, the first channel that we will have. Coming back here, so we have our base map, then we are using UV0 UV map and giving these two as an input to our this particular sample texture 2D node. It returns RGBA value. Okay, this RGBA value, we are ignoring the A value, we don't need it here. So when it goes to the base color only picks up the first three values, RGB. Now let's add tiling and offset here. Okay, so for that, let's drag and drop them, tiling and offset. Now we have seen that tiling kind of, expands or shrinks the texture along the tiles, right? And offset completely moves it to left or up. Okay, right, left, right, or up, down. So how do we use it to do the same on this sample texture 2D? So for that, we will need to add another node. We will press space. Then let's go and search for tiling and offset node. So the first input it is taking is UV0. Okay, it is using the same UV map. Then it needs the tiling map. Then it needs the offset. So what it is doing is it is operating on that UV0 map and changing it somehow. And it creates a new UV map for us. And this new UV map we are passing to this UV2 channel. Got it? Let's try to understand this UV map. Okay, so let's say we have 3 points on our cube, right? Let me just quickly draw them. 1, 2, and 3. All right, these 3 points we have here, and on our UV map they are converted to these pixels. All right, these 3 pixels will be used. So what will happen if we increase or decrease tiling? Basically, if we increase the tiling, this map, this positioning will expand. Okay, and if we decrease the tiling, then it will shrink. So on increasing, we can see it will give a far away value. When we shrink it, it will be like a zoom in, because these positions will now represent something very close. Okay, so it will be like a zoom in. And if we change the offset, basically it will move these 3 points together. So if we are moving in X, it will move in here. If we are moving in Y, it will move here. Okay, so this way they will work. All right, so this is the offset and this is the tiling. So this tiling and offset node, it is taking our default UV map and applying this tiling and offset on it. Then it creates the new values which we can use as a UV map. We pass these values to our sample texture 2D node, and then the resulting RGB value will be taken into the base color. Let's save our asset like this. Then let's go to the grass material and let's select our new shader graph which we have created, which is world position shader. So if I have done everything right, then everything should look the same. Let's switch it. Okay, so let me put it to the one, and you can see it is the same thing. Nothing has changed here. Now let's try to fix it. So we have learned about the sample texture and the UV map and the tiling and offset. Now to solve the problem of these tiles, what we need to do is we need to display the pixel which is based on the world position. So for example, if I move the center to somewhere else, the pixel that needs to be displayed here, it has to depend on the world position, right? Because my tile is getting moved to somewhere else. Okay, so let's go to shader. Let's press spacebar and search for the position node. Now this position node, what it will do is it will return the xyz position for a local xyz position. Basically we give it that, hey, this is my x1 y1 z1, and what it will do is it will give me the world position for this particular position. So from here I am getting x and y and z. One thing to note is that we do not require anything on y-axis, right? Because we are only going to change the color based on the x and z, right? If I move my tile on the y-axis, I do not want anything to change. It should display what it was displaying already. So let's split this position using the split node. So let me move it here. I give it as an input. Now I need to ignore the y position. Now this node gives me r as an x, g as an y, b as an z. There is no a here, okay, because we are giving three-dimensional vector as an input. Let's go here, and now we are going to create a vector 2. What we need is the red one and the b1, x1 and the z, right? We have to ignore the green one. So red and b. This has converted it to a vector 2, x and y, right? So we can use this entire thing as a UV map. So we just connect it to the UV input, and it will work as a UV map for us. It will it will give an output based only on the world position of the object. Okay, so let's see. If I click save asset here, everything should become continuous, right? So we can see it is better now, but let's try to see if it is actually good or not. So I'm going to move center tile, and it should remain continuous even if I'm moving it. All right, nice. If I change the tiling a bit, let's say take the center tile, move it, you can see it is still continuous. So this is the way we can create a world position shader, which uses the world position to create a kind of a UV map, and using which, if we apply tiling and offset, we will get a continuous world position based material. If you like this video, then please comment, like and subscribe it so I can create more videos like this. Thank you.